We use it every single day, but have you ever just stopped and wondered, how does Wi-Fi really work? It honestly feels like magic, right? Data just poof, appearing out of thin air. Well, what if I told you it's not magic at all, and the science behind it is something we can all wrap our heads around? So, for the next few minutes, let's pull back the curtain and take a look at the invisible signals that pretty much run our world.
Okay, so let's just dive right in. At its absolute core, Wi-Fi is just a really, really sophisticated two-way radio. Seriously, your laptop, your phone, your smart TV, they're all just talking to a base station, which is your router, using the exact same principle as a walkie-talkie.
And this 5-step process, this is the key to everything. Your device takes digital data and translates it into a radio wave. An antenna then sends it out, your router catches it, decodes it, and then shoots it out to the wider internet through a physical cable. That exact process, just happening in reverse at lightning speed, is how this is reaching you right now. Simple, right?
To really get this, we're going to go on a little journey. First, we'll explore those invisible radio waves Wi-Fi travels on. Then, we'll learn the language it uses to send all that data. We'll uncover the clever tricks it uses to avoid traffic jams, see how it keeps your connection secure, and finally, we'll take a peek at what's coming next. Let's get into it.
So if Wi-Fi is basically a radio conversation, what air is it actually traveling through? Well, that would be the radio frequency spectrum. Think of it as a huge invisible highway for all kinds of information. And let me tell you, that highway is incredibly crowded. It is jam-packed with TV broadcasts, cell signals, satellite communications, you name it. Wi-Fi has to carve out its own dedicated lanes, and it does that way up in the super high frequency bands, specifically at 2.4 and 5 gigahertz. Using a frequency that high is the secret sauce for how Wi-Fi can carry so much more data than, say, an old AM radio station.
Now, even within Wi-Fi, you've got two main options. Think of the 2.4 gigahertz band as a country road. Sure, it has a longer range and it's better at getting through walls, but it's also slower and gets super crowded with everything from your microwave to old cordless phones. Then you have the 5 gigahertz band. That's the superhighway, way faster, a lot less crowded, but it has a shorter range. Most modern routers use both, which lets your devices automatically pick the best lane for the job.
Okay, so we've got the radio waves, but that's only half the story. For your phone and your router to actually understand each other, they need to be speaking the same language. In the world of Wi-Fi, these languages are called standards, and as you're about to see, they have evolved to get incredibly fast over the years.
Just look at this timeline. It's absolutely staggering. We went from 11 megabits per second back in 1999, which is barely enough for one kind of low-quality video stream, to today's standards that can theoretically handle over 9 times gigabits per second. And you can also see here where they switched from those super confusing 802.11 names to the much simpler generational numbers we see now, like Wi-Fi 5 and Wi-Fi 6. Thank goodness for that, right? Makes buying new gear a whole lot easier.
But listen, all that theoretical speed doesn't mean a thing if your connection is constantly dropping out. The real genius of modern Wi-Fi is how it manages the absolute chaos of the real world to give you a stable, reliable connection. Now, if you've ever tried to fix a slow connection, you've probably heard this piece of advice. Switch your router to channel 1, 6, or 11. But why? What's the deal with those specific numbers?
So here's the deal. It is all about overlap. In that 2.4 gigahertz band, the channels are packed so close together that they actually bleed into each other, creating all this interference. It's like cars constantly drifting out of their lanes on a highway. It's a mess. But channels 1, 6, and 11, they're the only ones that are spaced far enough apart that they don't overlap at all. So when you choose one of them, you're basically giving your network its own clear private lane, so it isn't trying to shout over your neighbor's signal.
Another huge breakthrough was a technology called MIMO. If you look at your router, you'll probably see it has a bunch of antennas sticking out. Well, that's not just for show. MIMO technology uses those antennas to send and receive multiple streams of data at the exact same time to the exact same device. It's like turning a single-lane road into a multi-lane highway, and it massively boosts your speed.
But there's one more really clever trick that makes Wi-Fi so robust. It's a technology with a complicated name, OFDM. But the idea behind it is pretty simple. Instead of sending all your data in one big chunk that could get lost or messed up by interference, it splits it into thousands of tiny subsignals and sends them all at once. Think about it like shipping a fragile vase. You wouldn't just send it in one giant crate, right? You'd pack it into 1,000 small protected packages. That way, even if a few get lost, the important pieces still get there, making the whole connection incredibly resilient.
Okay, so we've got a fast, stable signal flying through the air. But this creates a pretty big question. If it's all just a radio conversation, what's stopping anyone from listening in? Well, that's the entire job of your Wi-Fi password and the security protocols working behind the scenes.
And just like the speed standards, security has evolved a ton. The original one, WEP, was found to be hopelessly insecure. WPA was better, but it has its own known flaws. For years and years, WPA2 has been the solid, reliable standard that most of us use. But the current gold standard is WPA3. It provides way more complex encryption, and, this is really cool, it even protects you on open public networks by encrypting your data individually. It's a critical feature for our modern devices.
So, where do we possibly go from here? Well, the race for speed and reliability is far from over. The next generation, Wi-Fi 7, has actually already started to arrive.
And the numbers here are just mind-boggling. We're talking theoretical speeds of up to 30 gigabits per second. It does this with much wider data lanes and this key new feature called multi-link operation, which lets a single device connect to the router over multiple bands at the same time. This creates a connection that isn't just faster, but also has incredibly low latency, which is absolutely essential for things like high-end gaming and augmented reality.
So from a simple two-way radio to a technology that can beam our entire digital world into our homes at tens of gigabits per second, the evolution of Wi-Fi is honestly one of the great stories of modern technology. And it really makes you wonder, with these invisible connections becoming ever faster and more powerful, what amazing things are we going to build with them next?